send them to me. I'll flash them and send them back to you. Okay, $5 for shipping or something. And that way you don't have to spend the money on a programmer. The thing about the programmer is that it's a one-time operation. Once it's flashed, you never have to do it again, because then you can software flash it later on if I ever release an additional firmware set. It's only that initial flash that's so problematic. So if you're interested in getting started, hook up with me. I'll give you my email address, and we'll work something out. The KillerB tool suite includes a bunch of different tools like ZBID, ZBDump. What I did was I tried to name tools after what their similar counterparts are that we all know and love. For example, ZBD Sniff, right? Well, ZBD Sniff we all know is like a password sniffer. Doug Song, classic tool, right? Well, ZBD Sniff is very similar, but for ZigBee networks. And ZBDump, like TCPDump clone for ZigBee networks. So to try to reduce some of that learning curve and what these tools are, that's kind of the naming mechanism I've gone through. Just to give you some ideas, some examples here. So on my Linux box right here, I have a ZigBee stick. And let me make my font size a little bit bigger here. OK. I've got a ZigBee stick on my laptop right here. And I've got a ZigBee node on a development board just sitting in the front of the room there. The ZBID tool just gives me a list of all the interfaces that exist on my system. So if I have multiple sticks, I'll see them all. This is kind of like ifconfig-a, if you think of it that way, OK? So one of the tools is ZBee Stumbler. ZBee Stumbler is very similar to the NetStumbler tool of classic lore. Okay? ZBee Stumbler is an active tool, just like NetStumbler, that sends ZigBee beacon request messages out. It's kind of like sending probe request messages out on a Wi-Fi network, but this is called a beacon request. And I'm looking for other devices to respond in the area. And my ZigBee device here responds, and it tells me, oh, here's my network ID. Okay? The source address is all zeros, which tells me that device is in charge of this network, because that's called the coordinator address. It doesn't have an extended PAN ID, and it's using the ZigBee standard profile. It's based off the ZigBee 2006/2007 version. So it gives me an easy ability to look for and identify ZigBee networks. If you want, you can run ZigBee. Just save the results to a CSV file as well. I wrote ZBee Stumbler. I found some tools, and I went to do a pen test for a customer. I started looking at their networks, and I thought, I really need to include a report about all the devices that I found. Well, I could cut and paste that screen scrape, but wouldn't it be better if I had a comma delimited list? So, with Python, it took me, I don't know, 2 minutes to add the CSV option. And now we have a little CSV format that we can import into Excel or whatever spreadsheet tool you use to be able to get that data as well. I don't even like Python particularly. I'm more of a Ruby fan. But this is a very simple interface to be able to get going and to build on some of these tools very, very easily. Okay. So in this Stumbler here, I saw that it's on channel 11. I'm going to run ZBDump, which is like a TCPDump clone on channel 11, and just save to a packet capture file called out.dump, of which I have about 10,000 similarly named files, and I don't know what one of them contains. Okay, so isn't that exciting? You guys are all like on the edge of your seats now. Woohoo! ZBDump, yeah! Before these tools were created, we didn't have anything for this. Okay, it's not that exciting. I'm hoping by talking about this that other people will want to start adding features and things like that. But at least gets us started so that now we can interface with these devices and start capturing data and manipulating it in ways that we're comfortable with. Okay. What I wanted to do next was spend some time walking through some attack scenarios. Not checking my phone here, just checking time. Okay. I wanted to walk through some attack scenarios and talk about different ways we can exploit ZigBee. This is taken from multiple pen tests that I've been on in attacking and exploiting ZigBee networks. It's when you're on a pen test, you can't really disclose some of the details, so some of them are kind of a little muddled, but I wanted to give you some real-life examples of how we can exploit ZigBee. Okay. Attack number one is called the seriously they do that key provisioning attack. How is it that we get the key on ZigBee devices? Okay. Every ZigBee device has to have a key, so how do we get that on there? Does the user enter the key on the device? Well, there's no keyboard. I mean, we could put little dip switches on. We could Morse code it out. No, that's not going to work, right? So how do we get that? How do we get that information on there? Two options. One, provision the key at the factory commonly across every device. Okay? Well, that works to a point. If you're doing like a private ZigBee run for your own private hardware, you might pick the key, provision everything, and that's fine. But if you're making ZigBee products that are going to be going to a bunch of different consumers, then the consumer needs a way to be able to set the key. Okay? You don't know what it's going to be ahead of time. So the way we do this in ZigBee networks is something called over-the-air provisioning, where when the ZigBee device joins the network for the first time, it gets the encryption key over the air. Okay? What protects that key delivery? Nothing, right? It's POP3 all over again, right? Precursor to SSL. I mean, well, that was like 1993, right? This is old stuff, okay? But that's what we're seeing here. We're seeing a return to some of these old issues and old problems that we know and love. Okay? Now, it's not that they just didn't care. It's that we don't have a good way to do it. There is no man-to-machine interface on a lot of ZigBee devices, so there's no way to enter keys very easily. Okay? So the tool to attack this mechanism is called ZBD Sniff. ZBD Sniff reads through ZigBee packet captures and extracts the over-the-air key delivery information. So the way I usually do it is I've got a bunch of packet captures in this directory, say for a target customer. I'll do a find. Okay, I'm saying find. I'm going to print with null delimiter instead of a space delimiter. And I'll look for all files ending in DCF or .dump. Okay? And I'll just move this up so it's a little bit easier to see. Okay. And I'm going to take that list of files and just pass them to ZBD Sniff with the xargs tool. No, that's OK. Oh, I see. Okay. I had dash print before the name argument, so that broke things. Sorry. One last time. There we go. OK. So what I did there was I ran a find. I said, find all the DCF files, which is the Daintree Sensor Network Analyzer Packet Capture File Format. That's the $8,500 commercial ZigBee sniffer tool. Okay. I didn't reverse engineer their file format because that would be a DMCA violation. I reproduced their file format. Okay. And then we have .dump files as well for libpcat files. Of all the files you find, print the names out, and then pass it to xargs and run ZBD Sniff. Okay? Nothing in this file, nothing in that file, nothing in these files. But this one, I found the network key going over the air. Okay? Here's the key itself, and here's the MAC addresses that were involved. As simple as that. And now we can use that key to then join the network as a ZigBee device, or just decrypt all the traffic on the network as well. And I'll talk about that in just a second. Okay, pretty straightforward. Okay, so that's attack number one. Let's talk about another attack. Okay, I call this the, wait, is this 1996 replay attack?